So Record is a program that's basically come out using from this website from Wageningen. And if you click on here, basically it tells you a little bit. So you go to this website, this is what you see in the page, tells you a little bit about the program. And you can download two different programs. There's Record. This is Record for DOS, and this is Record for Windows. They do the exact same thing, except Windows, of course, has a shell-type program. Today, I'm going to talk about the Record for Windows. And there's a couple differences between the two programs, which I'll highlight. So if you download the program for Windows, and that really takes about 2 minutes, it's very, or not even, it's very, very quick. It's a simple program. You get an opening screen, and it tells you a bit about the program, the types of populations it can. So what does it do? It maps markers for a single linkage group. And these are the type of populations it can use: backcross, F2s, recombinant inbred lines. You can, of course, use double haploids under the backcross command, but your distances are overestimated from the backcross. And basically, the way it works, like most mapping programs, it tries to minimize the total number of recombinations. Record has this, basically the MST map program uses Record, the same exact algorithm as Record, just to give you an idea. And you can even export Record results into JoinMap and other programs if you like. Okay. So you open the program, this is what it gets. It really only does 2 or 3 things. You have to start a new project. You load the data, and these are, you load the data, so you can actually capture load from file or just hit this button over here, load data. And this is the log file. This is the log file for Group 8 that we created. Here are your markers. Here's the genetic data, the header. So nothing new, the exact same file that goes into MadMapper and JoinMap and other type files. So the first thing, so you go to your ops. So the next thing is options. So really, what's really nice about this program, the way to use it is you just go through the little icons over here in that order, and that's what you do. And so you hit the options command, and this is what you're going to see. There's very few options. The first one is what's called the maximum additional recombinations when seeking plausible alternatives. This is not the minimum distance to include a marker in your genetic map. This is the minimum genetic distance or recombination between alternative genetic maps. So in this case, so what it does, it goes through a number of iterations of the map, in this case 5, and these 5 maps cannot be more than 10 centimorgans. The total distance cannot be 10 centimorgans apart. Okay, so it's looking for a resolution of multiple maps and give you the best map. The gap size, so this is maximum recombination allowed between 2 markers for them to be included, is 25 centimorgans, and you can choose Haldane or Kasambi. Go back to your, so you go back to your menu, and then you can hit calculate over here or in the calculator, and then you get a whole bunch of output. And I'm going to go through quickly what you see from the output, and you can see the output either in the log file or this file is automatically saved to the directory that you set up your project in as well, and it's called JM order. I think it actually means join map order, but because it's the same developers. But you'll find a file called JMORD, and it's basically a text file and has the exact same thing as your log file. So at the top of the file, it'll show you kind of the options. So this is what you've seen in the options. You had a maximum alternative recombination 0.1, 5 steps, Kasambi 25 centimorgans maximum. And basically you see a list of the markers that have, what's nice, it says it lists a set of markers that have the exact same basically haplotypes or basically genetic segregation. All right, so it's not going to try to, and what it does, it just chooses one of those. So it doesn't map all your markers at once in the initial steps. and so on, just to save time. And this is really important once you get to really high density maps. I'll give you an example. In Pepper we map 16,000 unigenes, but we only have 2,800 unique haplotypes, or 2,800 genetic bins in that map. So it's a much easier task to map 2,800 than it is 16,000, of course. And then you reassociate after the fact the haplotypes that are the same. It goes through 8 different replicates, and the last replicate is the best one, and it gives you the total genetic distance. These should be within 0.1 centimorgans, basically, which is your value. In the notepad, and this is truncated, it gives you the best order, best estimate of the order. And here's your order from 0, in this case, to 149. We had 150 markers. The total genetic distance, in this case, 160 centimorgans. And it gives you the genetic distance below this. Okay, so here's the exact same order of markers, and here's their genetic distance. So these markers are in the same genetic bin. They're all at the 0.417 distance in the map. So the DOS version basically has the exact same commands, but it's much, much quicker. What can take maybe 100, this subset of data set might take maybe 10 minutes in WinRecord, or sometimes an hour with a large data set. It takes literally minutes in DOS. With really, really large data sets, basically DOS is minutes. You can go in hours with WinRecord. But it's not days like some of the other programs like JoinMap, for example, in the same data sets really have taken us overnight or days to do the same linkage groups that we've done in Record in less than an hour. And so this, and especially with the DOS, it's really minutes. The thing though the DOS version does not do, it does not export the distances. Okay, so just export the order part of the file that I just showed you in the previous slide. And so with that order, you can get the genetic distances by importing that order into JoinMap, and then JoinMap is actually quite efficient once you give it an order, because then you're just asking it to calculate the genetic distances based on the order you already have. So that's something we've actually tested between the two programs. In the genetic order, the order is pretty much the same between the two programs, except for very, very close markers, less than half centimorgans, where honestly you don't really have the genetic resolution most of the time to make those calls in the first place.